I'm trying to solve a dispute between my children. They both want the same toy, and so I decide to put 100 marbles in a bowl. 50 of them are going to be pink, and if I pick one, Ariana is going to get to play with the toy first. The other 50 will be blue. If I pick a blue one, Micah will get to play with the toy first. This just happens to be their favorite colors, and it just happens to be an example of a hypergeometric distribution. So what would happen if I picked a blue one first and Micah got to play with the toy first? He would be thrilled. But the next time we use that bowl of marbles, there would be a greater chance that I would pick a pink one than a blue one. In fact, let's calculate those odds. So instead of it being 50 out of 100 like it was previously, now Ari would have a chance of 50 out of 99, or 50.5%, that I would pick the pink one and that she would get to play with the toy first the next time. And again, this assumes that I don't place the marbles back in the bowl. This might be a little bit more fair from their perspective, because if they didn't get to play with the toy first the last time, they would have a greater shot of getting to play with the toy first the next time. And in fact, every time they lost, their odds would increase. So say that the next time I still picked a blue one and Micah got the toy first, and Ariana thinks that life is horribly unfair, but the next time her odds would go to 50 to over 98, and she'd have a 51% chance. So I'm wondering if I actually might have a viable chance of convincing my 4- and 6-year-old that this would be a good alternative to picking who plays with the toys first. Anybody want to calculate the odds on that for me? I'm not thinking they're very good. All right, let's go with a business example instead of using my cute kids. So let's calculate the size of the, let's calculate the potential to select a female CEO out of a population of 500 when there are 40 women who are CEOs out of that population. In fact, we're going to do the numbers all the way from 0 to 10. So in order to do that, we need to use the hypergeometric distribution. So I'm going to again use the insert function, and I'm going to search it up. HYP is going to be the way to do it. And you know what? I was having trouble getting that to come up earlier. So what I'm going to do is I'm going to start typing, and it's going to come up. Oh, where'd it go? Come on, there we go. Oh, let me note too, you might have this other one with the exclamation mark, and that's for earlier versions of Excel, so you want to use the one without that. All right, and I'm going to go ahead and hit insert function so that we can see the function arguments. And again, I always say if you are a little unsure how to use the function, always use this, because you have this handy dandy hint right here if you can't remember what goes where. So sample S. So we are looking to see, in this case, what are the chances that 0 women would be selected? And we're going to go all the way through 10. So I'm going to set this up so I can copy and paste the formula. So I don't want this to be an absolute value. I want it to float. All right, so what is the size of my sample? Well, out of 500, I am going to randomly select 10 of those. The population of S, so the number of successes that are in the sample would be 40. Okay, and what is the overall population size? And that is 500. So I need to go back through and make all of the B1, B2, B3 absolute values so I can copy and paste my formula. And we also want, for our cumulative function, we want it to be false, because we want to know exactly that number of women, not that number or less. So I'm going to go ahead and hit OK. And so that gives us, we have a 43% chance of selecting no women, given those arguments. I'm going to copy and paste it all the way down. And there you go. We can also, like say we wanted to know the odds of picking 5 or more. So we can do sum, and we can select 5 or more, and there we go. So it's a pretty low chance of picking 5 or more women as CEOs, substantially less than 1%. Okay. Again, hope this has been helpful. If you've got any questions, go ahead and email or call me, and you can also stop by and see me during office hours. Hope you have a great night.